All right, everyone, welcome. Today we're going to talk about the independent samples t-test. I know the course is called ANOVA, but the t-test is a good introduction to that. I'm sure that all of you have studied the independent samples t-test, as it's supposed to be part of your intro stat course, but we'll review it as if you haven't really had much information on this before. I know that it's easy to forget stuff. All right, the t-test. The t-test is attributed to William Seeley Gossett, one of the kind of bigger names in statistics. Gossett worked studying the best yielding strains of barley, and this created some statistical issues. You can't really use a normal distribution with small samples, and that's what he was dealing with. He was dealing with some relatively small samples, and by small samples we mean less than thousands and thousands and thousands. He discovered a distribution that allows us to estimate the mean of the population when sample sizes are relatively small. And what that involves is estimating a population standard deviation from a new distribution and calculating the probability that is dependent on sample size. And we'll see how this involved a recognition that distributions tend to get a little bit more spread out when you have smaller samples. All right, so the t-test. The t-test replaces a test that you likely learned about as kind of an introduction to hypothesis testing, which was the z-test. Practically, you would use it for all situations that you would otherwise use the z for. It's called, interestingly, it's called the student's t-test because Gossett's employer didn't allow employees to publish their work. So he published the work under the pseudonym of student. And Gossett is my favorite statistician because his employer was the Guinness Brewing Company. Not a big fan of Guinness beer. I am a big fan of beer, though. All right, there are three different t-tests, so it's important to highlight that. One is called the one sample t-test. That's when you have a single sample mean that you're comparing against a hypothesized mean. The second is the independent samples t-test. Here, that's for comparing means drawn from two separate groups, two groups that have different people in them. That's the one we're going to talk about. There's also the paired samples t-test. That's for comparing groups that include the same people, like pre-post designs, or you might see this with dyads, like husband-wife couples, or something of that nature. Twins would be another example. Each have different formulas and different considerations, so do keep that in mind when using t-tests. Just to highlight what the t-distribution actually looks like, you can see that the shape of the distribution changes as the sample size gets bigger. And it starts to look pretty much like a normal distribution when you hit degrees of freedom of 30. Degrees of freedom, not really important at this point. It's a function of sample size. Larger samples give you more degrees of freedom. So you can see how we need to have a different distribution for every different sample size. And as we get bigger and bigger and bigger, we start to look a lot more like the normal distribution.